Okay, but so we will talk about the structure of the muscle fiber. Okay, so the structure which we are going to discuss, it is mainly of the skeletal muscle fiber. But before we start with the different bands and the structure, you should know that as such, the skeletal muscles are mainly they are made up of many fascicles, or what we call as the muscle bundle. So each muscle itself, if we take single muscle, then each muscle is made up of the so many different muscle fibers, or what we call as the muscle bundle. So direct muscle ni under there will be muscle bundle. Okay. So if you talk about each organ as skeletal muscle, then it is made up of the number of muscle bundles, or what we call as fascicles. So each muscle has so many fascicles. So if you take single muscle, each muscle will have so many fascicles, and they're held together by what we call the collagen layer, which is what we call as the fascia. So this is, as you see, this is the fascicle. So each muscle has so many such ultra fibers. As you can see, this is the fascicle. Okay. Now each muscle bundle, okay, each fascia, okay, if you take this single fascia, you can see this, it has so many fibers. It has so many fibers. These are all you see is so many fibers. This is single fascia and it contains so many fibers. This is single muscle they have taken, and each muscle bundle has so many muscle fibers. So whatever you see inside this, it has so many muscle fibers. It has so many muscle fibers. So try to understand that each muscle has so many fascicles and it has so many muscle fibers. Okay. So each muscle bundle has number of muscle fiber. Each muscle fiber is lined by plasma membrane, which we call as the sarcolemma. Remember that for muscle fiber, this cell membrane is termed as sarcolemma, and the cytoplasm is known as sarcoplasm, and it is a syncytium or syncytium condition. Why? Because it is multi-nucleated condition. There has been division of nucleus, but cytoplasm had not been divided, so it is termed as syncytium. The ER, endoplasmic reticulum, is termed as sarcoplasmic reticulum. Okay, and it is rich in calcium. This is also important MCQ. Now see, if we take about the muscle, if we talk about single muscle fiber, then it has a large number of small filaments or fibrils. So each of these muscle fiber is made of large number of small filaments, or what we call as fibrils, which is what we call as myofibrils. Okay. So try to understand each muscle has so many fascicles. Each fascicle has so many fibers, and each fibers is made of so many small fibers, which we call as fibrils, which we call as filaments or myofibrils. Okay. And this fibril these are also termed as ultra fibers, or this fibril contains alternate dark and light bands. It contains alternate dark and light bands. Okay. So this is where we talk about A band and I band. Now, as such, the dark band, it is what we call as the A band. The light band is what we call as the I band. That is why this alternate dark and light pattern will give the striped appearance, or what we call as the striated appearance. Okay, and this dark is made up of myosin protein, while light is made up of actin protein. So these two are important proteins for this. So light bands contain actin, is called I band, or isotropic, and dark band contains anisotropic. So remember, it is the A dark band, A term stands for anisotropic, while I term stands for isotropic. That means it is dependent on the light it will allow to pass. So if you focus a plane polarized light, then if it will not allow the light rays to pass, it is anisotropic. If it will allow the light to pass, it will be isotropic. Okay, so from that, those terms had been derived. Now, try to understand that actin is thinner, myosin is thicker. So this is where the structure which you see. Okay. So ideally, as such, if you talk about this appearance, then there is alternate pattern of actin. So this is what you see. This is the light band, high band, and this is what you see. This is what you see is the A band. Okay, so you are here. This is the real electron micrograph. You see, this is the I band, and this dark which you see is A band. Okay, so this is continuously overlapping. As you can see, this is continuously overlapping. That this A band is overlapped by I band. This A band is over. This is A. This is A band, as you can see. Till this point, it is A. Okay, and it is overlapped by what we call as this I band. Okay, so it is much clear, beta. A band and I band pattern. Over here also you can see.
Yes, sir.
This is A band. This is I band. This is A band. This is I band. Okay, again this is A. This is I. So it is continuously all. Okay. So if you talk about the I band, if you talk about the I band, so this is, as you see, this is also the I band. You see, this is in center. You can see this line. In center, you can see this line. Over here also you can see this line. Okay, beta. That line is zigzag line, or it is termed as the Z line. It is termed as the Z line. This is Z line. Over here also you can see it is Z line. Got it, beta? So this Z line is mainly in each of these I band is connected to the Z line. Each of these I band is connected to the Z line. So Z line will pass from the center. So Z line will pass from the center. Okay, beta. So as such, this Z line
Okay, sir.
will bisect it. Okay, Z line will bisect it. Okay, you should know that. Now this thin filaments or I band is attached to Z line, as we all know. Now, if you talk about the thick filaments or A band, then they are also held by something called as M line. Now see, if you see this part, beta, if you see this part, okay, then in this part, as you can see also over here, if you talk about this diagram, if you talk about this diagram or this part, you can see in this region you can only see A band. There is only A band. It is not overlapped by I band. It is not overlapped by I band. Okay, better. If you see only this part, it is only dark band. There is no I band. So that part is termed as H zone. That part is termed as H zone. Over here, this is H zone. Got it right? So H stands for Hansen's line or Hansen's zone. H stands for Hansen's line or Hansen's zone, as you can see over here. Okay. So till now we have discussed about beta A, I, Z, and H. Clear this much? A, I, Z,
Yes, sir.
Z, and H. Now there is a thin line in this H zone. There is a thin line in this H zone, and that is what we call as beta M line. That is what we call as M line. So they have mentioned that the thick filaments are held together in the middle by a thin line termed as M line. Okay, so see, and the central part of thick filament, which is not overlapped by thin filament, is what we call as H zone. So as you can see, over here, this is the H zone. Now in this, you can see this line. Can you see this line over here, which I am highlighting? Okay, right. So that thin line is what we call as the M line. This line is what we call as the M line. So in the center of H zone, there will be a light line. There will be a light line which will be passing through, and that line is what we call as the, and that line is what we call as the M line. And that line is what we call as the M line. Okay, so this line which is in the center, it is what we call as the M line. So you should know about A band is dark, I is light. Okay, H zone is the part where A is not overlapped by I, so it is only A part. In the center of H, there is a thin line. So in dark band, there is a thin line, that is M line. So M line is thin line in dark band. Then there is Z line, which is through which the I is connected to this Z line. I is connected to this Z line, as you can see. So A, I, H, M, and Z. I hope this is now clear. Yes or no, beta? Clear? Got this much?
Yes, sir.
Rahi, what is this band over here? What is this band? A. This is I. This is I. This is Z line. This is okay. This is Z line. Again, then this part where only you can see the dark band, this region, which I am highlighting, this part. Okay, which I am highlighting. This part is what we call as the H zone. In this, it is what we call as the H zone. In the center of H zone, there will be M line, which is the thin line. Okay, and this area and this region right between two Z line is termed as sarcomere. This region between two successive or consecutive Z line is sarcomere. And sarcomere is the unit of functional unit of muscle contraction. Is the functional unit of muscle contraction. It's the functional unit of muscle contraction, which we'll talk about now. So you should know that the portion of the myofibril between two successive Z line is called functional unit of contraction. It is termed as sarcomere. Okay, in the resting state, the thin filament will overlap the thick filament partially. Okay, that you should know. So these are important sentences from this part, and this is important from this part. So starting from muscle has fascicles or bundles has fibers has ultrafibrils or myofibrils have dark and light appearance. So A and I band, there is Z line, there is Z zone, there is M line. So now if you have any problems, better you can ask me. You can see the diagram from textbook, and if you have any issues, you can ask me.
Sir, why the bands are called isotropic and anisotropic?
It depends on the see. It is mainly based on the physics phenomenon. So when you focus or when you just incident the light rays on the A band, okay, it is a dark band, so it will not allow most of the light to pass through. Okay, it will be sort of opaque object. Okay, or it will not allow the light to transmit through. So it is termed as anisotropic. While light band will allow the light to pass through. So it is termed as isotropic in comparison to what we call as the dark bands. Okay. So as such, if you focus the 10 polarized light, then if it is the light is scattered identically in all direction, we call to that as the isotropic ideally. And if you talk about the anisotropic, okay, then in that case the light is not scattered, okay, as such, or what you can call like it is not uniformly like scattered. Okay, so it is mainly scattered on some particular aspect in more amount. So it depends on the amount of light absorbed and the amount of light scattered through it. That is why anisotropic terms are used better. Okay. Got it right now?
Yes, sir.
Okay. So any other problem you should know about H zone, M zone, A zone, I. Now then only you can get the next part. Okay, beta. So this much should be clear.
Okay, sir.
Hmm. Okay, so now next is about the like how what will happen during the contraction. It is also very important to understand. There are some questions depending upon that. So if you talk about this thing, okay, see right, this is where you see this is the given three conditions. That is, one is what they call is the relax condition. Okay, one is what they call is the relax condition, as you can see over here. Of muscle. Then this is the contracting condition, and this is the maximal contraction. This is the maximal contraction. So I hope you got these things. Got it, beta? Okay. Now see,
Yes, sir.
we'll talk about each of these and the questions which they ask. Okay. So see, this is what you see. The zigzag line you see is the Z line. So right, this area is what we call as, what is this area called? Distance between two successive Z lines. What we call it?
Sarcomere.
Sarcomere. Okay, it is what we call as the sarcomere. Now see, this is what you see is the I band, and this is what you see is the A band. Got it? This is the A band, and this is the light line is the I band, and this is the this sort of send line is the A band. Got it, beta?
Yes, sir.
Okay. So see, during normal relaxed stage, so let's say when the muscles are not being used, we are relaxed. When we are not lifting any weight, whether when we are not writing anything, when we are not walking, when we are just lying ideally on the bed, let's say. At that stage, when the muscles are all the muscles are, let's say, relaxed. Then in that condition, the I band will overlap A band only till the certain extent. As you can see, till here, the I band is overlapping the A band. I hope you can get that. Okay, so the I band is overlapping this A band. I hope you can get that. Got it? This much?
Yes, sir.
Same here. You can see this is same. In this are over here. How many sarcomere you can see, right? Can you tell me how many sarcomere are there?
2.
This is one. This is two. Okay, such questions have been asked better from diagrams. Now see, as you can see, during the relaxed stage, I band is partially overlapping the A band. I band is partially overlapping the A band. And that's why the only region where we can see the A band is termed as beta edge zone. And Rahi, what will be in the center of edge zone? What will be in the center of edge zone?
M line.
M line. So this is where the M line will be there. Okay, now there is contraction, but the contraction is normal. There is no, it is not maximal contraction. It is not maximum amount of contraction. It is normal contraction. So if you see better over here, this sarcomere distance has decreased. This sarcomere distance has decreased. See over here, you see this distance was was more. Okay, if you talk about this over here, then the distance was quite more. If you see in the relaxed stage, then the distance was quite more. Okay, so if you see over here, beta, okay, just a moment. Let me have use some other color. So if you see over here, right, this distance is quite more, no, but this distance from here to here is quite more. Now, if you compare this distance to this one, it has decreased better. You compare this one to this one, right? This has decreased, yes or no?
Yes, sir.
So what it shows that during contraction, the distance between two sarcomere will decrease. Got that thing? Distance between two sarcomere will decrease. Now
Yes,
see,
sir.
Right, if you take this area, look at where I am highlighting. If you take this area, okay, then see it is also decreased. It has also decreased better. This area has also decreased, which is the A zone, which is the edge zone beta, which is the edge zone. See, edge zone was this much big. Now here it has reduced to this much. Here it has reduced to this much. This is the edge zone. Got it beta?
Yes, sir.
Why? 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 Because the what we call as this I band during contraction is covering the A band to a greater extent. If you compare to this part and if you compare over here, okay, let's say if you compare this region and this region, then you'll get an idea that there is this I band have come closer. These I bands have moved in this direction because the distance between two Z line has decreased. So the I band has moved closer to one another. No, better. Yes or no?
Yes, sir.
Okay, so the H zone also decreases. So the H zone, so distance, the sarcomere or distance between two Z line, okay, it also decreases. Then the area of H zone beta will also decrease. Got it?
Yes, sir.
Okay, now see, they ask all this question, huh? That what will be in the contracting stage, what will be in the maximum contraction. So as you can see over here, these are two sarcomeres have seen. Now just compare Rahi, this area, it was quite big, this area was quite as such. If you compare this area, the relaxed state to this area beta, if you compare this relaxed stage between two sarcomeres to the maximal contraction stage, beta. Okay, you can, if you compare this and this one, then you can see visible difference, no? Yes or no, Rahi?
Yes, sir.
So over here, let's say if the distance between two Z line was 2 meters, then here in this case, it will come down to 1 meter beta. So it is the case of the maximal contraction. It is the case of the maximal contraction. Got it?
Yes, sir.
Now see, the other things which you should notice is, see this I band has completely touched one another. This I band has completely touched one another. As you can see. See અહીંયા I band પોતાને એકબીજાને overlap કરી લે છે, હે ને? કે નહીં?
हाँ, sir.
Okay, so this over here, if you see, this I band is completely touched. And there is, and which zone has disappeared beta? From here, which zone has disappeared?
H zone.
H zone has completely disappeared in the maximal contraction. Then what about I band? I band length will has decreased, no beta? I band area has decreased because it has come nearer. As you can see, I band length decreases. What about A band beta? A band length. What will be the case?
Remains same.
Remains same. Why? Because A band is just overlapped. The length is not decreased. Then what about distance between two Z line beta? What will happen to that?
Decreased.
It is also decreased to half. It is also decreased to half because this area is also decreased. So during maximum contraction or maximal contraction, H will disappear. Okay. 2 I band or the length of the I band will decrease. Length of the I band remains the same. And the sarcomere distance will decrease to the half. And the sarcomere distance will decrease to the half. Got it better?
Yes, sir.
So this is what happens beta in relation to the structure in contraction. Okay. Now Do you want to understand sliding filament theory? Yes or no, Rahi? Or are you aware about
No,
that?
sir.
Okay, so are you aware about that? Are you aware about the structures, beta?
Yes, sir.
Okay, this is Rahim. From this, myosin is important, especially these questions they ask. Okay, that which part is active ATPase. Okay, I'll just show you some of the things in relation to this. Just wait a moment. It is for this. It is these are from my lectures for Government of Gujarat, but I'm just showing you the images. These lectures were in Gujarati, but you'll get an idea of what is there in the English part. So see right over here, you see this is this actin is in this manner. This is actin. Okay, this is what you call as the actin beta. Got it? This is the actin part. Right. This is how the actin is, and this actin can combine. This is each monomer is G actin, polymer is F actin, as you know. Okay. Then beta, this is myosin.
Yes, sir.
This is what we call as the myosin. As you can see, this is the myosin. Okay, I hope you can get the myosin. Then, if you talk about the troponin, this small structure, this is troponin. And then this is tropomyosin. This is tropomyosin. This is what we call as the tropomyosin. This is actin. Got it, right?
Yes, sir.
Okay. Now, as such, you should know that troponin has basically three different sites. Troponin has three different sites. There is I, T, and C. So this is the tropomyosin binding site. This is the calcium binding site. And this is the inhibitory site. Okay, because as you know, this troponin, okay, will mainly cover the regions for myosin binding on actin. So that's why it has these three sites. That's why its troponin has three sites that you should know. Okay. Now see, you should know about the heavy and lighter myosin. So if you talk about this head part, okay, this head part, it is the what we call as this is the head. Okay, this is the middle part. Okay, or the arm part as we call it. So this is, and then this is the tail part. So head has ATP binding region. Head has ATP binding region that you should know. Okay, and this is also termed as heavy meromyosin. The tail part is termed as lighter meromyosin. Okay, and this is the actin binding site. Okay, now see, this is the sliding filament GIF, as you can see. See beta, this masking is removed. Now this calcium binding will remove the masking. So this myosin, as you can see, these are myosin. So these myosin filaments can bind to the actin, as you can see, because otherwise it is masked by tropomyosin. The tropomyosin masking and troponin is removed by calcium ions, and that's why this can bind to this myosin. You can see this can bind to this. I hope you can see this GI if you can get this. Got it, Rahi? This is what happens in sliding filament.
Yes, sir.
This is what happens in sliding filament theory, beta. Okay, beta, got it.
Yes, sir.
Hmm. That is why the cross bases are formed and the sliding filament happens. That is why this muscle contraction happens. Okay. So, Rai, what you want? What else you want to cover from this chapter or anything else?
About joints.
Okay. From this, beta ribs is important and vertebral column is important for questions. Okay. Then they ask maximum questions from the joints as well as from the diseases. Okay, so from this chapter, the most important part is as such what we call as the joints, and then about the edge zone, S zone, I zone, all of these things. Apart from that, you should also know about the different diseases which they had given. I mean, they usually ask two questions from this chapter if they need to ask them. Okay, just right, just a moment, okay, just a moment. Okay, but so see, as you know, when the bones are in contact with one another, okay, that is where the joints are formed. And usually, when the bones are in contact, there is cartilage in between. There is cartilage in between. Normally, what we Gujarati માં આપણે જેને ગાદી કહીએ. So that is where cartilage is there. So cartilage will prevent the bones from coming in direct contact with one another, and then ensure that if the bones will come continuously in contact, then it will be painful, and as such there will be wear and tear. So to avoid that, there are cartilage in between. Apart from that, there are also some synovial joints. There is presence of synovial fluid. Okay, and it just works like the grease as such. So mainly, then these joints are attached to ligaments. Okay, so the ligaments are the part through which the muscles are bound to the bone. As such, the two bones are attached to one another for movement, and then there are tendons through which the muscles are bound to the bones. So the place where muscles are bound to the bones, that is what we call as tendons, and the place where ligaments are bound to the bones, two different bones, that the two bones are joined by the ligaments as such also, and in between there is cartilage. Okay, so better there are three types of joints are there. That is Fibrous joints. Just a moment. If I have some chart, let me share it. Okay, just a moment. Just give me a moment. Okay.
Okay, sir.
I think I have something about that. Okay, just. I don't know. PDF is not opening. So. Just a moment. I'm just trying to open the PDF. Okay, right, just a moment. This is good. Okay, I'll just share it with you. Okay, but I just also got the images of that. So right, first we'll talk about the textbook part. Okay, and then I'll also say some of the things which is important for questions. But am I audible, Rahi? Hello.
Yes, sir.
No. No better. So textbook says that there are three types of joints as such. Okay, that is what we call as the fibrous, cartilaginous, and synovial. Okay, so these three types are the all of the joints can be classified in these three types. This fibrous will not allow any movement. So if you know about the different bones of our cranium, okay, that is temporal and okay, occipital and all those the frontal, and so all those bones are immovable because they are joined by what we call as the sutures. Okay, what we call the suture. It is a French word. It means આપણે ગુજરાતીમાં જેને ટાંકા કહીએ, sutures. They are immovable. And it is made up of the cranium beta. It is made up of the collagen. These are rich in collagen. Collagen is always immovable. So this is in the seen in the flat skull bones, which is fused to form the cranium, or what we commonly call as the head box. Okay, and this is the example is sutures. Okay, this is fibrous joint. There is no movement. Then cartilaginous is normally between two bones, that is our limbs, bones of our limbs, bones, the part between the vertebra and the vertebral column. So there is cartilage in between. Okay, so it is in the between vertebra, and it is permitting limited movements. So it permits the limited movements as such. And then the so fibrous, no movement at all. Limited movement will be seen in the case of the cartilaginous. And then there is most important, that is synovial joints. So they have a fluid filled capsule or synovial cavity, which is mainly, it is just mainly seen in our knee joint. Okay, knee joint in our legs, then in our hands also, and at the shoulder region and all. So there is greasing material which will prevent the friction. Okay, and it can allow considerable amount of movement. So like we can run, we can stretch, we can rotate our hands. All of this is because of synovial joints. So it helps in locomotion, Okay, in different sports also it is used, can be used as the movements are allowed. It has many types better, like ball and socket joint between humerus and pectoral girdle, hinge joint between, that is in the knee. So if you can only, like this ball and socket joint in humerus and pectoral girdle, that is the shoulder part. Knee joint is the our knee joint in the legs. Pivot joint is in the atlas and axis. Gliding is between the carpals and the tarsals also, as such is between the in our hands. Okay, saddle joint is in the carpal and metacarpal of the thumb. Okay, so these are the some types. I will take in detail beta. So see, this is beta cranial bone. They have this fibrous tissue. This is immovable. Okay. If there is cartilage in between, that is between the two vertebra, there is cartilage. It is cartilaginous joint. And synovial, you can see this is, there is this cavity. You can see this cavity. It is synovial fluid. So it is our, this is what they have shown is there is cartilage also surrounding. There is cartilage. Then there is fluid, and these are the bones. This is what you see is the bones. It is for the common joint is the knee joint. There is a membrane surrounding, that is synovial membrane. It contains synovial fluid, which is the function of synovial fluid is greasing to prevent friction. It is to grease it, like just like in the factories and all, in the machines we apply grease. Similarly, okay, so this is the synovial joint, and synovial has many different parts types. Okay, so it is in the synovial fluid. They have also cartilage, like hyaline cartilage normally. So the example is the ball and socket joint beta. So you should know the examples from this. Okay, they ask examples mainly for questions. Shoulder joint, hip joint, and in the middle ear, incus and stapes. Okay, there is ball and socket joint. Then the shoulder, the humerus, that is the upper limb bone. Okay, forelimb, upper bone, which articulates with the shoulder part. Hip has the femur, that is the strongest bone of the body, joined with the acetabulum cavity. So you can rotate our legs. We can do different movements. Okay, then there is a hinge joint. Hinge is like hinges which we see in the doors, like elbow joint. You can only move it in one direction. આપણા ઘરનો દરવાજો એક જ directionમાં બંધ થાય ને અને એક જ directionમાં ખુલશે. That is hinge joint. Similarly, there is knee joint, ankle joint. Okay. Then there is interphalangeal joint, that is between the as such between the fingers. Then elbow joint. Okay, same. Okay, which is joined to the radioulna. So elbow joint is also one direction you can move your elbow. Okay, you cannot move in opposite direction. You cannot rotate it in the opposite direction. Okay, you can only bring it close to the humerus. The knee joint, as you can see. Okay, and the ankle joint in the tibia fibula part. Okay, with the then there is saddle joint. Saddle joint is wrist joint. You can, okay, wrist movement can only be done in certain planes. Then thumb joint, and the joint between the metacarpal and the phalanges. Okay, so free movement is only certain movements is can be done, otherwise it is restricted. Then the pivotal joint. Okay, it is the pivotal joint is mainly between the skull, okay, and the radio and ulna. Okay, so as such in this the movement is very rarely permitted. Okay, and the gliding joint, it is between the two vertebrae. It is between the two vertebrae, as you can see, or between carpals, between tarsals. Okay, and in the clavicle joint to the sternum part. That point you can see gliding or sliding, where the bones will slide upon each other. Now, right, they have mentioned one of the things over here, that is pre and post zygapophysis. Pre and post zygapophysis. Do you know what is it, beta? Pre and post zygapophysis.
No, sir.
This question was asked, okay, in 2017 about pre and post zygapophysis. So beta, if you take the vertebra, like this is one vertebra, let's say, and then we have, this is the another vertebra. Okay, so this is what we call as pre-zygapophysis, and this is what we call as post-zygapophysis. So these two vertebrae are joined because of this structure. There is cartilage over here. In between over here, there is cartilage. This part, there will be cartilage beta. So it is for joining of two vertebrae, pre and post zygapophysis, that you should know, which they have mentioned over here. So it is mainly right, it is informative. You need to know examples. Now, if you have any specific problems from this, you can ask me.
No, sir.
Okay. The other part is better diseases that you should know. Okay, diseases, muscular dystrophy, tetany, osteoporosis are important. Muscular dystrophy, tetany, osteoporosis are important. Okay, right. So, anything else better from this chapter?
No, sir.